Hydrocarbons are compounds of carbon and hydrogen only. To represent the organic molecules, we have different types of formulas. The empirical formula gives us the least detail. It tells the simplest ratio of different types of atoms present in the molecule, while the molecular formula contains the types of elements and their exact number of atoms. Ratio to calculate the molecular formula is the molar mass of molecular formula divided by the molar mass of empirical formula. We also have the structural formula, which tells us about the atoms bonded to each carbon atom in the molecule. Also, the displayed formula, which shows a 2D or flattened version of the ball and stick model. The skeletal formula, which shows a simplified version of the displayed formula, which has all the symbols for carbon and hydrogen atoms removed, as well as the carbon to hydrogen bond. So this is how we find the empirical formula, by using the ratio of the molar mass of the molecular formula divided by the molar mass of the empirical formula, and then multiplying the elements.
Any compound step by step. So firstly, we chose the longest continuous chain of carbon atoms, which was this. And we started numbering from the side nearest the substituents, which was this, since we have two here. And if there are more than one substituents, we use the Latin prefixes D3 tetra, and we name them alphabetically. So its name is 2,2,5,3-methylhexane. I will make a three-dimensional figure for you, which we can name it. The black dot symbolizes the carbon atoms, whereas the white dot symbolizes the hydrogen atoms. We chose the longest continuous chain of carbon, which was this one, or this one. And we started numbering from the side nearest the substituents here. And if there are more than two substituents, we choose the Latin prefix D3 tetra, and we name them alphabetically. So its name is 2,2,4,3-methylpentane. This figure is in skeletal structure. So, firstly, we chose the longest continuous chain of carbons, which was this one. 1, 2, 3, 4, 5. Then we put the numbers, we started numbering, and near the substituents we put the prefix D3 tetra, and the name then alphabetically. Its name is 2,3,4,3-methylhexane.